Today's lesson is on finding slope in a table, an input-output table, and if we're given two coordinate points. So these are the same notes from yesterday. We remember that slope of a linear function is the rate of change. Rate of change is the same as slope. And it's the rate of change between the dependent variable y and the independent variable x. We remember that slope is abbreviated as m. Think mountains. Mountains have slopes. Slope is abbreviated m. Slope is also expressed as a ratio, a fraction of two things. And our fraction is slope is the change in y, remember change in y, over divided by the change in x. Okay? And we're just going to take a little time to think about the four different kinds of slope. Your slope can be positive, it can be negative, it can be zero, or it can be what's called undefined. So yesterday we talked about three of these, mostly these two, positive and negative. So positive slopes have increasing lines. What does increasing mean? Right, going up, a line going up. Good. An increasing line is a line that is moving upwards. But we know it goes on and on forever. And we remember that as x increases, y increases, both things are increasing, both variables are going up. So this is really important. When you see a line that's going up, this is giving you part of your answer. When you're writing m equals a number, you should know that that number is positive. Right? We can't get the number here because we don't have a grid, but we should already know we have a positive slope, and then my fraction. If it's a negative slope, that means the line's going down in a downwards direction, or what we might refer to as decreasing line. A decreasing line. So when the line is going down, that means our slope is going to be negative, not positive. That's important. Because now we have part of our answer. M equals a negative fraction, whatever that fraction is. We'll leave it blank because we don't have that grid. Okay, negative some number. Okay. And with decreasing lines, as one variable increases, as x increases, the other decreases. Think inverse, think opposite. One's going up, the other's going down, and that makes a decreasing line. Now there's also two special versions of slope. When a line is not going up or it's not going down, we consider these zero and undefined slope. A zero slope is a horizontal flat line. Horizontal flat line. So, looks like this. And in this picture, well, this is important, zero slope. Oh, what is the slope? It's zero. These are easy. If you see a horizontal flat line, you don't have to do any work. You should remember, or you should know, that these do not have slopes. There's no slope or a zero slope. Horizontal lines have a slope of zero. Easy answer. In our vocabulary here is going to say, as x increases, as we move along the line, do we go up or down at all? Did we move along the y-axis? No, right? It doesn't go up, it doesn't go down, it stays flat. So we would say y stays the same. Lastly, you might be already thinking about what an undefined slope is. An undefined slope is a vertical line. The last type of line we didn't discuss yesterday. Vertical lines, lines that go up and down, don't have a slope. It's not the same as zero. It's actually called undefined. So we would write our answer as m equals undefined. There is no number that we can actually put to represent the rate of change. But we say it's undefined. And we say the slope is undefined because there's no change in x. There's no change in the x variable. Okay. So what would I be meaning here? There's no change in x. We think about our strategy from yesterday. We picked 2 points on the line and we calculated the change in y over the change in x. So how much the line is going up, change in y, over how much the line is moving left to right, or the change in x. And we can see on this line that we don't know the units, but we can see it goes up 1, 2. It goes up a certain amount of units. But does it ever move left or right? No, right? It doesn't go over and up. It just goes up. Or if I'm thinking of it from this point to this point, it goes down. So because there's no change in x, that would mean our denominator of our fraction way up here would be 0. There's 0 change in x. And if we remember, you can never, ever, ever divide by 0. You cannot divide by 0. 5 divided by 0, you can't think of a number. So we consider these vertical lines having an undefined slope. No change in x, you can't divide by 0, therefore the slope is undefined. And now we're going to accomplish today's goal, which is I want to find slope, I want to find the rate of change in y over the change in x in a table and given 2 coordinates. And this is actually a good lesson because to do both of those things, to find slope or rate of change in a table and 2 points, we can see we can only use one strategy here. Okay? So to determine the rate of change of this linear function, remember linear functions can be tables, graphs, equations, we want to calculate the changes in y, which I'm going to do right here. So our problem says determine the rate of change of this linear function. And we'll see why it's linear in a second. But I'm going to calculate the change in y, and then on the other side, I'm going to calculate the changes in x. So I put these little symbols right here to remind myself, find the change in y, find the change in x. Because once we do that, we know slope is the change in y over the change in x. So if we can get values for each of these, we're done. We can just put them in our fraction and call it a day. And here's how we do that. I'm going to focus my attention on the y column. 5, 2, 1. First thing I notice, are the numbers going up or down? They're going down, right? So they're decreasing here. 5 went to 2. How much did that change? Right, it changed by 3, and because it's going down, we would say negative 3. So again, I'm finding the change in y. Here's a y, here's a y. How did it change? 5 went to 2. It went down 3. And then, if I looked at my next 2 rows here, 2 and negative 1, I can ask myself that same question. How did 2 change to negative 1? It still went down, so it's still going to be negative, but now it's going to be negative 3 again. 2 minus 3 is negative 1. So we find the changes in y, and then, well, there's part of our answer, negative 3. Let's find the changes in x. Changes in x are from 2 to 0. Again, it's going down. Now we're looking at x column. It went down how many? Down 2. Next side, 0 to negative 2. It went down 2. My change in x is negative 2. Remember from the first unit, same good. Same signs is going to lead to a good answer. Good is meaning positive. We can actually change this to our final answer of slope of, or the rate of change of this table is 3 over 2. And because that's a positive value, we know that if we graph this line, it's going to be increasing. And then for example 2, I'm just going to set you up, and then you're going to determine the rate of change of the line that contains these 2 points. So thinking about the second part of the goal. Here's 2 points. I want you to determine the rate of change. I want you to determine the slope. And the only thing I need to tell you or remind you of is these coordinates are made up of an x value and a y. An x value and a y. And look at tables. They're made up of x values and y values. So we can actually just make a table from these 2 coordinates. Make a table from these 2 coordinates. First coordinate was 4, -3. The second coordinate was -3, 4. And now you can go ahead, just like we did up here, and find the changes in y, find the changes in x. And if you do this correctly, you should end up with m equals -1. See if you can get that answer. And because it's negative, we should know this is a decreasing line. So see if you can get that answer, and then practice the problems that follow.